Scientists just confirmed something buried under the surface of the moon that is so heavy and so strange that even the people who found it are still arguing about what it actually is. We're talking about a hidden mass so large that picturing it means imagining a pile of metal 5 times bigger than Hawaii's Big Island, sitting hundreds of kilometers below the lunar crust, quietly pulling on everything that passes overhead. And it's only one piece of a bigger puzzle, because the closer we look at the moon, the more it seems like the moon doesn't want us there. Landers keep crashing, missions keep failing, and even now, with decades of spaceflight experience behind us, expensive spacecraft keep slamming into the surface instead of touching down. I'm Arif Hassan, and this is AH History. Start with that hidden mass, because it's the strangest thread in this whole story. Beneath the South Pole-Aitken Basin, the largest and oldest impact crater in the entire solar system, sits an unusually dense concentration of material buried far below the surface. This was first identified back in 2019 by planetary geophysicist Peter James at Baylor University, using gravity data from NASA's GRAIL mission, combined with topography from the Lunar Reconnaissance Orbiter, and follow-up research through 2025 and 2026 has continued to study it in more detail. Researchers estimate the anomaly's excess mass at roughly 2.18 quintillion kilograms, extending to depths of at least 300 kilometers, possibly much deeper, and it's heavy enough that it's pushing the basin floor downward by more than half a mile. Nobody's completely certain what it actually is. One theory is that it's leftover metal from the giant asteroid that carved out the basin billions of years ago, a chunk that never fully melted or dispersed and instead sank into the lunar mantle, frozen there ever since. The other theory is that it's residue from when the moon was young and covered in a global ocean of molten rock. As that magma ocean cooled, denser minerals may have sunk unevenly and clumped together in this one spot rather than spreading out evenly. If that's what happened, this mass isn't leftover asteroid at all. It's a fossil of the moon's own early, violent history. What makes it stranger is that the anomaly doesn't sit where you'd expect. It's offset by roughly 400 kilometers from the center of the basin. If it were simply leftover impactor metal, you'd expect it roughly centered under the crater it created, not shifted off to one side. And that mismatch is part of why researchers, including a 2025 study led by Jeffrey Andrews Hanna at the University of Arizona, are still actively debating which explanation actually fits. This isn't the only gravitational oddity on the moon either. Scientists have known for decades that the moon's gravity isn't smooth the way Earth's is. It's lumpy, with regions called mass concentrations, or mass-cons, where gravity is noticeably stronger than expected, first noticed in the late 1960s when early orbiters started drifting slightly off their expected paths for no obvious reason. It took decades of better instruments and more precise gravity mapping to understand why. These mass-cons tend to cluster around old impact basins, tied to ancient asteroid strikes that reshaped the moon's interior. But the scale of the mass hiding under the South Pole is on another level compared to anything found before, and it happens to sit directly beneath the exact region every space agency and private company currently wants to reach, because of the water ice hidden in its permanently shadowed craters. That brings us to the second half of this story, because landing at the moon's south pole has turned into a genuine graveyard for otherwise excellent engineering programs. In 2023, Russia's Luna 25 mission attempted a landing near the lunar South Pole, more than 50 years after its earlier missions made history, and crashed into the surface instead. That same year, Japanese company ispace attempted its own lunar landing with its first Hakuto-R mission and also failed. In 2025, the company tried again with an upgraded lander named Resilience. Everything looked fine until the final stretch of descent, when a laser system meant to measure distance to the surface stopped giving reliable readings, and the lander crashed, its second lunar failure in under 3 years. India's first serious attempt at a soft landing, Chandrayaan-2, also ended in a crash in 2019, after its lander veered off its planned trajectory during final braking and lost contact with ground control. American company Astrobotic's Peregrine lander missed the moon entirely in January 2024, after a fuel leak sent it tumbling back toward Earth. That same year, Intuitive Machines' Odysseus lander achieved a partial success, touching down but tipping over onto its side, limiting how much of its science equipment could actually be used. That's failures and partial failures from Russia, Japan, India, and multiple American companies, all within the same decade, all involving highly trained engineers using some of the most advanced navigation technology available. That's not bad luck happening once, that's a pattern. Part of the explanation goes back to that lumpy gravity. Since the pull isn't uniform everywhere on the moon, a spacecraft descending doesn't experience a smooth, predictable tug the whole way down. It gets nudged unpredictably as it passes over hidden mass concentrations, especially the extreme one under the South Pole. A guidance computer following a pre-calculated flight path can get thrown off just enough to miscalculate speed or position during the most sensitive seconds of descent. And when you're slowing from thousands of kilometers per hour to a gentle stop with no atmosphere to help, even a small miscalculation can be the difference between a landing and a crater. That lack of atmosphere is the other major piece of the puzzle, and it becomes obvious once you compare the moon to Mars. NASA has gotten reasonably good at landing on Mars, even though it's much farther away, because Mars has a thin atmosphere engineers can use to deploy parachutes, bleeding off speed before the vehicle gets close to the ground, followed by airbags or a hovering rocket platform for the final stretch. The moon has essentially none of that. Every lunar landing has to be what engineers call a fully propulsive landing, slowing entirely through precisely timed rocket burns from thousands of kilometers per hour down to a dead stop, with zero margin for error and nothing to fall back on if something goes wrong. That also makes fuel management an enormous constraint on its own, since every extra second spent hovering or correcting course burns through propellant that can't be replenished mid-descent. There's a human factor too, or rather, the lack of one. Every crewed Apollo lunar landing succeeded without a fatal landing accident, largely because a human commander could improvise in the moment in ways autonomous systems still struggle to match. During Apollo 11's descent, the onboard guidance computer was leading the spacecraft toward a boulder field, and the commander took manual control to steer past it with only seconds of fuel to spare. Robotic landers don't have that option, and remote control from Earth doesn't solve it either, since even a few seconds of radio delay is far too slow to react during the most sensitive phase of descent. Where these missions are trying to land has also gotten dramatically harder. Early lunar missions mostly aimed for a simple, direct path to the equator. China eventually broke that pattern with a landing on the moon's far side, but the missions grabbing headlines now are aiming for the South Pole specifically, because permanently shadowed craters there can trap water ice for billions of years, ice that could eventually support drinking water, breathable oxygen, and rocket fuel for missions heading further into space. Landing there requires a far more complicated three-dimensional polar trajectory, flying directly over that enormous hidden gravity anomaly, through terrain where the sun sits so low that shadows stretch for miles, making it hard for cameras and sensors to judge distances or spot safe ground. None of this makes a South Pole landing impossible. India proved that in 2023 with Chandrayaan-3, becoming the first country to successfully land there. And the story behind that success matters. After Chandrayaan-2's crash, engineers pored over every scrap of telemetry the spacecraft had sent back, rebuilt their approach with extra fuel margin and stronger landing legs, and tried again. That pattern shows up throughout the history of lunar exploration. NASA's earliest robotic lunar missions in the early 1960s failed at a strikingly high rate before the program eventually worked out the kinks that made crewed landings possible. Nobody looks back at that stretch of failures and calls it a disappointment, because those crashes were the price of admission for everything that came after. So when you put it together, a gravity field warped by ancient impacts, and one uniquely massive, still unexplained structure beneath its most famous crater, zero atmosphere to soften any landing, a distance too far for real-time human correction, and the most scientifically valuable region on the entire moon sitting directly on top of the hardest terrain to land on, it's clear the moon isn't just close and familiar the way it's sometimes treated in conversation. It's a genuinely hostile place to land on, and every failed attempt is quietly generating the data that makes the next one safer, mapping the gravity field in finer detail, and building in backups for exactly the kind of sensor failures that have doomed recent missions. If space mysteries like this genuinely interest you, follow this channel, because the moon still has plenty of secrets left, and we're only beginning to understand how strange and stubborn our closest neighbor in space actually is.